Let's take a look at factoring method number 2. Here again we have another pre-example number 2, and we're asked to distribute. You should remember from Algebra 1 that when you multiply a binomial by another binomial, you were taught a mnemonic device, FOIL, to help you stay organized. FOIL is really just helping us all distribute the same way. What we're doing is we're going to distribute the 25x squared to the 2x. 50x to the third would be first times first. Then we distribute 25x squared to the 1 at the end. Those are my outer expressions being multiplied, and that will give me 25x squared. After that, we go to the 3 and we begin distributing 3. 3 times 2x. 6x would be my inner two terms being multiplied. And last, we multiply 3 times 1, and that's the last term in each parenthesis being multiplied. We get 3. What FOIL as a mnemonic device does for us is it allows us to all write our answer in the same order, and this makes it easier for us to compare our solutions. But since we're putting everything in standard form anyway, it isn't totally necessary. You could multiply this however you really want. When I multiply, I would get 50x to the third plus 25x to the second plus 6x plus 3. Oftentimes when we FOIL one linear binomial by another, we end up with an x squared as my largest power, and my outer and inner terms end up being like terms and combining. However, we see we have a third, second, first, and 0 power. That means I have no like terms, so nothing can be combined. This is in what we call standard form. My largest power is up front here on the left, and I go smaller, trickle down until I have no power left. All like terms have been combined if there were any, so this is, again, in standard form. Now, this one's a little bit more difficult. How do we put this back into that form? This seems a little bit more challenging, but really there's another way we could be looking at this problem. What if I just had a big oval in front of 2x plus 1 and asked you to distribute the big oval into the parentheses? What would you do? Well, you would get 2x times oval plus 1 times oval. But what is the oval really standing in for right now? The oval really represents that 25x squared plus 3. So we ended up distributing the entire quantity of 25x squared plus 3 to both the 2x and the 1. Now, can we distribute 2x to 25x squared plus 3? And can we distribute the 1? Why not? 2x times 25x squared. 50x to the third. 2x times 3 plus 6x plus 1 times 25x squared. 25x squared, 1 times 3, and again, that won't always be a 1, just so we know, plus 3. Well, this is not in descending exponential order, so I need to do a little bit of rearranging since the commutative property tells me that the order we add or subtract doesn't matter as so long as the sign stays with the number. 50x to the third plus 25x squared plus 6x plus 3. Now, I just found that same solution, but with a different approach. While I FOILed on the first example, since I had a binomial times another binomial, here I really just thought of it as distributing my entire first quantity into my second quantity. This logic is a little bit better when we're trying to go backwards. What this shows us is that we can factor a greatest common factor out of the first two terms and the last two terms. Then we would end up with an entire quantity that matches in the first half of the problem and the second half of the problem, and then I could just take that big expression and really factor that whole thing out front the way I would normally factor a 2 out front. Let's see what this would look like. We're going to look at that as one group and this as another group. What's the greatest common factor out of these terms over here? If you like the way I showed when I broke the numbers all the way down into prime factorization, knock yourself out. I'm going to show a little bit less of that work now and jump right into the answer. The greatest common factor between 50 and 25 is 25. The greatest common factor between x to the third and x to the second is x to the second. But I can't just divide this big mess by 25x to the second. I'll also have to multiply it out front. 25x to the second. What's the greatest common factor between 6x and 3? The greatest common factor is 3, and since this doesn't have an x, I can't include it. But I can't just divide by 3. I'll also have to multiply in front by 3. Now I need to use my pretzel method to reduce the inside of these big parentheses. 25x² is sitting out in front of the parentheses. Whatever sign is here in the middle will go with the number I divide by over here. We'll talk more about that every time it comes up. So a positive 3 is sitting in front of these big parentheses. If we reduce using the pretzel, what's left inside? What's 50x to the third divided by 25x to the second? 50 divided by 25 and x to the third divided by x to the second. We recently reviewed properties of exponents, so this shouldn't be too bad. We have 2x plus, what's 25x to the second divided by 25x to the second? The answer is not 0. This doesn't cancel. Cancel is when you're adding and subtracting and only zeros left. This is reduced or simplified to 1. 6x divided by 3. 2x. Positive 3 divided by positive 3. Positive 1. Now, do we have another greatest common factor? Maybe it's even greater than the greatest common factors we've seen before. Our greatest common factor is 2x plus 1. I have a 2x plus 1 in this green set over here, and I have a 2x plus 1 in this orange set over here. Since they both have a 2x plus 1, I'm going to factor the 2x plus 1 out front. I won't show my multiply and divide step like I did over here. I'm just going to pull it all the way out in front. You don't have to write 2x plus 1 squared because when you factor something out, it's something that was distributed. It's not, there won't be 2 of them. Since it was distributed, they each got 1, but only 1 factors out front. If I factored it out, that means I divided and multiplied. That means that those 2x plus 1s right there and there are gone. What's left inside? We'll be left with 25x to the second plus 3. As of right now, this problem is done. Sometimes we'll be able to take it further, but this example, we would probably just stop right here anyway. What we did was we factored by grouping. We grouped the first 2 terms together and the last 2 terms together. Then we applied factoring techniques with greatest common factor to each of the smaller groups. When we did that, we realized we had a jumbo common factor of 2x plus 1, a binomial expression, And we factored that all the way out, and we were left with 25x² plus 3 inside. Again, to check your answer, you can redistribute and see if you get back the original problem. Since this was a pre-example, we distributed and then factored, so we sort of checked that our distribution was right by factoring and getting back the same original problem. Let's try example 4 together. If we want to factor by grouping, we'll underline the first two terms and the last two terms. We don't have to underline 2 terms. It could really be 3 terms and 3 terms, or 2, 2, and 2 terms. You just have to have the same number of terms in each underlined section. Now, we're going to identify the greatest common factor in each of these 2 groups. If you think you could give it a shot, press pause and try it by yourself now. So you either just tried it on your own or you wanted to do it with me. Let's go ahead. 30 and 55. The largest number they both have in common is 5. This is 5 times 6, or 5 times 2 times 3. This is 5 times 11. The greatest common amount of x would be x to the second power, or x times x. Here, this is a little bit more tricky. These 2 terms look like they don't have anything in common. Well, for starters, you always use whatever sign is in front of the expression's leading term, plus, and if they have nothing in common, well, that just means that the greatest thing they have in common is 1. Underlined, underlined, greatest common factor. Now, since I'm also going to multiply it out front, I'm just going to go over here and bring it out front, 5x². Same with the plus 1, bring it out front, plus 1. Parentheses, parentheses. These parentheses are where I'll put this reduced expression. And this set of parentheses is where I'll put that reduced expression. Now I'll use my pretzel method, some purple pretzels. 30 divided by 5 is 6. X to the third divided by x to the second, x. Plus is still plus. 55 divided by 5, 11. X to the second divided by x to the second reduces down to 1. No x's left here. 6x divided by 1 is 6x, and 11 divided by 1 is 11. These match. 6x plus 11. That's my super common factor. Pulling that all the way out front, 6x plus 11. What will be left inside? Remember, if you factor it out, it divided, it's gone, it reduced to 1. The only thing left inside will be 5x² plus 1. There we have our answer, and it can be verified with distribution. If you are afraid to try 4 by yourself, maybe now you're ready to try 5 by yourself. I definitely suggest pressing pause and trying it on your own. You need to make mistakes in order to learn what not to do. If you're watching this, I hope it means that you gave it a good try by yourself. Underline, underline. Greatest common factor. x² is the biggest thing that both of these expressions have in common. Plus sign, this needs a plus sign. 7 is the greatest thing those 2 terms have in common. Bring it out front. Bring it out front of what? Parentheses, of course. Pretzel, pretzel. What goes inside? 2x to the third divided by x², 2x. 3x² divided by 3x. Negative 3x² divided by x² is negative 3. The signs matter. That's what I was warning about. You really need to know your rules for positives and negatives very well, because right now we've only seen very simple examples, but they do get way more complicated. 14x divided by positive 7, we get 2x. Negative 21 divided by 7, negative 3. If it's not negative 3, if it's positive 3, then it's deceived you. It's not factorable. You need to pay attention. Sometimes they look factorable and they're not. They're actually prime. Prime things cannot be factored. Here's my super common factor, 2x minus 3. They both have one. I have one here and I have one here. Bringing that out front. 2x minus 3 factored out front. If you're factoring it out, you divided it out. What is left inside? X to the second plus 7. That's our answer, and I promise, again, this can be verified by distributing or using FOIL to expand and open this up and see if you get back the original question. I hope you found this section of the 5-part factoring series helpful. If you feel like you've mastered this type of factoring, be sure to give the video a thumbs up for your records. However, if you have not mastered this type of factoring yet, give this video a thumbs down so you remember that this is a video that probably deserves more of your attention. I won't be offended, I promise. It's to help you remember what you need to practice and maybe to take out a little bit of steam on the lesson video that maybe frustrated you a little bit, but eventually you'll be able to come back and give it a thumbs up and show the video who's boss. Have a great day.